Well, good morning, everybody. Today we are starting on a new topic, which is topic 3, and it's all about functions, the word functions, which is this word right here. And today's lesson, we're going to start with 3-1 relations and functions. This lesson is more of a concept, more of the words that you need to know rather than math. And there's not a lot of math in this lesson at all. No calculation. It's just more like, do you know it or do you not know it, right? So it's either a yes or no question. But before we start this lesson, let's actually take a look at this review on how to write order pairs, right? So there are 4 order pairs here: point A, point B, point C, and point D. And in this lesson, all you have to know is to write the order pairs from the graph shown here. Like, for example, point A, if you take a look at point A, it's the x value is at -2, the y value is at 2. So we're going to say point A will be at -2, 2 because of -2 and 2 here. Likewise, point B is the x value for point B is 2, the y value is 1. So for point B, it's going to be 2, 1 like this. And then point C and point D are the ones that actually got confused by a lot of students. So you notice that for C, the x value is 0, the y value is 2. So that means it's going to be 0, 2. And then for point D, lastly, the x value is 5, the y value, since it's not above or below the x-axis, is 0. So for point D, it's going to be 5, 0. And these are the previous stuff that you need to know for today's lesson. So let's move on to lesson 3-1. Well, in 3-1, the title is called Relations and Functions. So first, I have to tell you what is a relations. So here is an example of a picture. Think of a place with a vending machine, such as at a mall or at a school campus where you're having lunch. Well, there are certain machines where if you press the button, it'll give you certain drinks, and you press the button, like this button number 6, it'll give you nothing. So in this particular vending machine, if you press the number 1, you get a Fanta. If you press the number 2, you get water. If you press the number 3, you get a Sprite. If you press the number 4, you get a Pepsi. If you press the number 5, you get water, which is the same as if you press number 2. And if you press number 6, it'll ask you to press it again because there's nothing comes out, okay? So let's fill in this table where X, which is the input, is the button that you choose, and Y, which is the output, is the drink that you're getting. So let's say if I press the 1, what kind of drink will I be getting from this vending machine? So you take a look at what's inside this box, and the output is Fanta. So you press the 1, you get a Fanta. What happens if I press the 1 again? Yes, I'm going to still get a Fanta, right? Now, if I press the 3, what's going to happen? Well, according to the picture, I'll get a Sprite, okay? And if I press the number 6, I'll get nothing. So there's nothing really here, right? So I'm going to press it again. And if I press the number 5, I'll get water. And if I press the number 2, I'll also get water, okay? So far, based on this table, the machine is working properly, because if I press the 1, I get Fanta as is stated. If I press a 3, I'll get Sprite as is stated. If I press a 5 or 2, I'll get water as is stated. And if I press a number 6, I'll get nothing as is stated, right? So this whole chart, right, an X and Y, we call that a relation. So I'm going to type it on the screen. A relation is just a set of order pairs. And here we got 5 order pairs. We have 1, Fanta, 1, Fanta, 3, Sprite, 5, water, and 2, water, and that's a relation. So every single set of order pairs that you see in the math class, they're all relations. Now, there are certain relations, there are 2 types of relations. The ones that are function and ones that are not functions. So far, this machine is working properly, is functioning properly, until I write the following. If I press the 2, I'll get Pepsi. Now, can you tell me whether this machine is working properly, functioning properly? No, because what happened when you press a 2? Somehow the first time you got water, and when you press the 2 again, you get a Pepsi. So when you have one output and having two different outputs, then it makes it not a function. In other words, this machine is not working properly. So in order for it to be a function, what is a function? I'm going to type it in here. So a function is a set of ordered pairs where each input has only one unique output. So that means if I press the 2, I better only get one thing, which is just water, not anything else but water. If I press the 1, I better just get one thing, nothing but Fanta, right? So if you have one input and somehow you have two different outputs, then it is not a function. For example, let's say another example is, let's say the input is a person and the output is a birthday. Well, can one person have two birthdays? No. One person can only have one birthday, right? If one person having two birthdays, then something's wrong, something's weird, something's not working properly, or just something doesn't not make sense at all. So therefore, a function, again, is a set of ordered pairs where one input or each input has a unique output. That's it. The next word you have to learn is, what is the domain? The domain is the set of x values, and you're going to write it in numerical order. So since the domain here are 1, 2, 5, I don't count the 3, then you're going to write it in a notation set, which you're going to start from the lowest number, which is 1, and then you write 2, and then you write 3, and then you write 5. 1, 2, 3, and 5. 6 does not have an ordered pair because when you press a 6, there's no output. So therefore, 6 is not an ordered pair. So it's going to be 1, 2, 3, and 5. Okay? And then for the range is the set of output, which is the set of y values. Well, in this case, the output is all the drinks here. Well, there's not really any particular order you're going to write because they're not numerical values. So all you have to write is just the drink's title, which is Fanta, Sprite, Pepsi, and water. And then that's it. So that's all you have to do for every time you have a problem. You're going to tell me, is it a function? Is it what is the domain, and was it a range, right? So is this a function? This is a no, not a function, because when you press the 2, you get two different drinks. So this is not a function. So as soon as you have this, weird stuff happen, then this is not a function. Let's take a look at more examples. In example 1, it says determine if a set of ordered pairs is a function and find its domain and range. So in example 1a, there are 5 different ordered pairs. There's 2, 7, 3, 6, 4, 6, 5, 7, and 6, 1. So the first question is asked, is it a function? So first, we have to look at, well, when you press the 2, are you going to get anything other than 7? So I see that, other pairs does not have a 2 except this one, so 2, 7 is fine. What about 3, 6? If you press the 3, you get a 6, and that's fine. What happens if you press the 4 and you get the same output as when you press the 3? It still works, right? So imagine when you press the 3 and press the 4, you get the same drinks. So it works. The machine is still working properly. And so on and so forth. So when you press the 5, you get a 7, which is the same results when you press the 2. And then when you press the 6, you get a 1. So it looks like this machine is working properly. So is it a function? The answer is yes. Okay. In the domain, you have to order them from least to greatest on the x value. So it's going to be 2, 3, 4, 5, 6. So you're going to put an open bracket, 2, 3, 4, 5, 6, close bracket. And in the range, I see 7, 6, 7, and 1. Now, if you see 7 twice, you don't have to write it once. And you're going to write in numerical order. So the smallest y value I see out of these 5 ordered pairs is 1. Then the next smaller one is 6. And the next smaller one is 7. And your range has these 3 unique outputs. Okay. Let's take a look at one more, which is 1b here. Is these 4 ordered pairs constitute a function? So first I look at, if you press the 3, I get a -1. That's fine. If you press the 4, I get a -2. But again, if you press the 4, I get a different y value. I get a 6. So something's wrong here. When I have 4 as an input, I get 2 different outputs. That's the same as saying that the same person have 2 different birthdays. That does not make sense. So is it a function in this case? It's going to be a no. What is the domain? It's a set of x values. So look at all the x's in each order pair. I see there's a 3, 4, 4, and 5. And you don't have to write the 4 ones. So you're going to write in numerical order 3, 4, and 5. And then for range, I see the y values as -1, -2, 6, and 8. So for the range, I'll put open bracket. It should be -2 first and then -1 and 6 and 8. So again, you have to write from least to greatest. -2, -1, 6, and 8. We're going to work on more on determining whether something is a function or not a function and find its domain and range. In example 2, we're going to take a look at this diagram, this type of diagram, and then find the domain and range and determine is it a function. In example 2a, I see that the order pair 3, 6, 4, 6, and 5, 8. Every time you see an arrow, it means that it is a order pair. So when 3 is pointing to 6, it means the order pair 3, 6. When the 4 is pointing to 6, it's going to be 4, 6. And then when the 5 is pointing to 8, it's 5, 8. Well, is it a function? Let's take a look at these 3 order pairs. Well, when I press the 3 and I press the 4, I get the same drinks. Or that's like saying that 2 people have the same birthday. And it makes sense, right? And then this person, or this number 5, right? When you press the 5, you get an X. So is it a function? Nothing wrong with that. So it's going to be a yes. Now here's the good part for domain and range. You notice that this circle already have all the X's, which are the domain. So all you have to do is just recopy that. 3, 4, and 5. And then for the range, it's going to be 6 and 8. It should be a bracket, actually. A bracket. So it's very easy to identify domain and range when you're given a diagram of the input and output. Let's take a look at this example again, 2b, right? So there are certain names here, and some of them are actually in certain periods, and some of them, the names I just made it up. And look at, there are Janet, Isabel, Eric, and Ava. And these are 4 different birthdays. Now, let's take a look at whether it makes sense. So I see that Janet has 1 birthday, Isabel has 1 birthday, but somehow Eric has 2 birthdays, so it doesn't make sense, and Ava has 1 birthday. So is it a function in this case? No. What's wrong? Because this guy has 2 birthdays, so it does not make sense. So what is the domain? The domain is all the names there. So all you have to do is put the bracket and just write the names. Literally write their names. Janet, Isabel, and I'm running out of space. I'm put the bottom, Eric, and then Ava. Okay, so those are the domain. And then your range would be your output, which is your birthday. So May 6, July 7. And by the way, these are just made up birthday. They're not, I don't think they're the actual birthday unless I'm lucky at guessing. So that's your domain and range. In example 3, we're going to talk about whether a graph is a function, and same thing, and find its domain and range. So here's a shortcut for you. There's 2 ways to do it. One is if you're given it something called discrete graph, which is just a bunch of dots with no lines, then all you have to do is do something called a vertical line test. So what I want you to do is use a ruler or straight edge, and I want you to scan the graph, right? Vertically scan the graph from left to right. So if you go from left to right, as long as your ruler only touches the graph at one point, then you are fine. So you're going to scan from left to right, right? This dot only touches the ruler once, and you keep going, this dot only touches the ruler once, and then keep going, this place only have 1 dot touches the ruler once, and then keep going at this place, there's only 1 dot touches the ruler once. So if you scan from left to right, and there's only 1 dot touching the ruler, then it is a function. So is it a function in this case? Yes. Now let's say if you forgot the vertical line test. Another way to do it is write out the order pairs. Like for example, this dot is -3, 3. This dot is -1, 2. This dot is 1, 2. And this dot is 2, 1. And then you just do what you just did in example 1 and example 2. You could do it this way. But of course, if you don't want to do it this way, the fastest way is to use a straight edge and scan from left to right to see if all the dot touches the ruler only once at every single point. Well, what is the domain? All you have to do is look at the x-axis, the x value. So I see that there is a -3, there's a -1, there's a 1, there's a 2. So just write from least to greatest. So it's going to be -3, -1, 1, and 2. Or you could just look at the x value here, which is the domain. -3, -1, 1, and 2. Well, the range, you just have to look at the y. So you're going to turn your ruler horizontally, and then you scan, right? So I see that this dot is at 1, there are 2 dots at 2, and then 1 dot at 3. So it's going to be 1, 2, and 3. So range is going to be y equals 1, 2, and 3. As stated here, the y values of the 4 order pairs, 1, 2, and 3. Let's take a look at another example, another discrete graph, right? Again, discrete means just a bunch of dots in a graph with no lines. Well, in this case, we're going to do a vertical line test. Again, we're going to scan the graph from left to right. So starting here, I see that there's only 1 dot touching the ruler. That's fine. As I keep going, there's only 1 dot touching the ruler once at this area. That's fine. And as I keep going, I somehow have 2 dots here touching the ruler at 2 different places. So this makes it not a function. So is it a function here? We're going to say it's a no. Okay. And then domain, all you have to do is scan from left to right and then look at the x value. So -3, -1, 1, and 3. So we're going to write that. So -3, -1, 1, and 3. And then for the range, I look at the y-axis, right? I'm going to flip the ruler horizontally, and I see that it's at -1, 1, and 2. So it's going to be -1, 1, and 2 like this, okay? And then that's how you find domain and range from a discrete graph. The last example, which is also example 3, we're going to take a look at 3C and 3D. Now, these are called the continuous graph because now you start seeing lines connecting 2 dots, right? Sometimes has 2 dots, sometimes has more than 1 dot. Like, for example, I could just make a dot here for this example. So it doesn't have to be 2 dots all the time. It could be 3 dots, 4 dots, and as many dots as we want, and then use a line to connect them. So is it a function for 3C? Let's do the same thing. So I'm going to scan the graph from left to right, and I notice that, well, it's going to be, let me see, at -3, and I'm going to keep going from left to right, and I see that the line is only touching my ruler once at every single part of the graph up to here. So is it a function? The answer is yes, it is a function because it's only touching the ruler once at every part of the graph, right? Then for the domain, now this is the trickiest part. The domain, you notice that there are only 2 points, but there's a lot of points in between the lines. So you cannot really write out every single x values. I mean, not only there is -3, -2, -1, 0, 1, 2, and 3, but there are decimals and fractions in between 2 integers, right? So there's no way for you to write all the numbers for the domain. But what you could do is you could write something called interval notation, which you have done it in 1-4, topic 1, section 4, when you were doing linear inequalities on the worksheet. So for domain, I look at the smallest x value, which is -3, and then the largest x value, which is 3. And since these 2 dots are closed circle, you're going to use a bracket. So you're going to be -3, comma 3 like this, right? And it's going to be a bracket. And then for range, it's going to be, so you're going to go like a elevator. So the lowest is -2, which is right here. And as you go up, the highest point is at 1 here, right? That's the highest point. So the lowest y value is -2. The highest y value is 1. And since they're closed circle, you're going to use a bracket again, not parentheses, a bracket. It's going to be -2, comma 1 like this, okay? And that's how you write domain and range in interval notation. Let's do one more. Right, the last example. In example 3D, again, it's a continuous graph because there's a line connecting the dots. So is it a function? Let's use a vertical line test to scan it. So I'm going to go from left to right. There's nothing so far. And as soon as I hit this area, I see that there's 2 points touching the ruler. So is it a function? No. That's like same as saying one person has 2 birthdays. So this is a no, not a function. Well, how do you find a domain? Same thing. So it's like a number line. You're going to scan. I see that the smallest x value is 1. The highest x value is 4. And they both have closed circle, like a fill-in circle. So you're going to write bracket 1, comma 4, close bracket. That's your domain. then for range, you're going to turn your rulers like this so that it looks like an elevator, right? So the smallest y value is -3, which is right here, and then you go all the way up until you hit +2 on the y-axis. So your range, the smallest y value is -3, and the highest y value is 2, and it's a closed brackets because they're both closed circles. And that's how you find domain and range. Well, this is the end for the lesson, and in the next 3 minutes, we'll teach you or remind you how to get to the Pearson homework 3-1 relations and functions. Thank you.
Hey everyone, so to get to your homework, first you go to my CNUSD website and then you click on the top of the page, my CNUSD, to log in. Well, you're going to type in your username and your password. Well, in this case, your student ID and your password. Then you go on to resource. I think for you guys it's resource. And then you go to a place called Pearson Savas Easy. Pearson Savas Easy. I'm not quite sure how you say that word, but it's Pearson Easy. Click on that. And you get to this pop-up page. And you're going to click on your class textbook. So you click on this right here. This is called Envision Integrated Mathematics 1 2009 Common Core. You click on that, a new window pop up again, and you see 3 different colors. The green color is your online textbooks. I teach from this textbooks. So if you don't have a copy, an actual copy, you could always go to here and click on the appropriate sections that we're teaching. But to find your online homework, you look at the reddish, orangish box in between, in the middle. It's called classes. So you're going to click on here, click on classes, and depending on which period you're in, there will be new assignments here. So you're going to click on the click into the assignments and then do your homework, and then that's it. Well, inside the homework, there are problems for you to work on which allow you 3 attempts before they give you the final answer. So for example, for this problem, if you accidentally got a wrong answer, it'll tell you keep trying. Then you type in another answer, and if it's wrong, then it'll give you one more chance. And the 3rd time that you got it wrong, it'll tell you the answer right away. So, but you could always get help by viewing an example on this part of the feature. So it'll tell you what to do step by step until the final answer. So you could always refer to the question, help view an example, or you could use help me to solve this to actually work it step by step. So there will be more answer boxes for you to fill in, but at least it will help you on your learning. Now for this problem, what do you do when you get it wrong, right? So to get a point or to get scores on that homework, then you click on similar questions and you keep practicing until you get it right. So if I were to click on similar questions, you notice that the questions changed. It's different from the previous one. So let's say this time you got it right. Let's say x is equal to 5, right? Well, if you got it right, it will tell you well done, okay, and then you move on to the next problem. So you click on next to move on to the next problem, like this. And once you finish all the problem, I believe the next thing is for you to make sure that you answer all the questions. If there's anything that is not answered, make sure that you go back and look at it like this, right? So this is not answered. But let's say assume that if you finish your all of the questions on your homework, then you go to the bottom, I believe. Oh, actually, this button right here says submit my work. So you click on it and then boom, I only got 3% just because I only answered one question correct, the rest I did not answer. So in order for you to get at least 80% or any good scores, make sure that you answer every single question and it's correct, not incorrect, for you to get as many points as possible on your homework. If you have any questions, please contact me.